Okay, in this next STM and TREF example, what I want to do is show something that is a little bit more real world than what I did in those first couple of examples. Where those first couple of examples, of course, were about the simplest thing we can do with TREF and are intended to help get us warmed up. So what I'm doing in this example is I'm creating a bank account app. Again, that's going to be a ZIO application. I'm going to start looking at the run value here, and that's going to be this for expression that you see right here. So what I do is, again, starting with a TREF, I want to create a TREF that has this initial value of 100. Then I'm going to commit that. I'm just going to hover here for a moment. And you see that when I call commit, that's going to return a ZIO value. So what I do then is I take that ZIO value and I call map on it. And I use the value inside of it. I call that B. That's going to be this value right here. And with that, I create a new bank account instance right here with that value B. So then if I come over here, you'll see that account is an instance of a bank account. So far so good. Nothing too terribly new. The map might be a bit new, but once you think through the process of what I did there to have a ZIO value, and then I just call map on it to create a new bank account, I think you'll be okay. Next, I call print line to show to us that we have $100 in the bank account. Then I'm going to use this do withdrawal function 3 times. And that code is right here, but let's skip that for the moment. And I just want to note that the first time I call it, I'm going to pass it our account and say, I want to get $50 out of there if I can. Second time I call it, I'm going to say, try to get $70 out of there. And of course, we know that's going to fail because we only have $100 in there. So this one will fail. And then I'll try it again with $30. And that one will succeed. So you'll see the first one will succeed, second one will fail, and then the third one will succeed. And one thing that's important to know is that I am calling commit inside of this code down here. So the transaction down here is actually all going to be run and committed down here. That is important to know. And you can infer that from the UIO type right there, but I just want to be clear about that. And now coming back up here, what I want to do with account is after we've used it these times here, I want to call get balance on it. And get balance is a method in the bank account class. We'll look at that in just a moment. And I want to call commit on it, of course, because I'm getting that balance. And then when the application ends, I'm going to print the final balance. And then we are done with the run value there. So now let's come down here and take a look at the do withdrawal function. You can see it takes a bank account and an amount as the 2 input parameters. I already mentioned that it returns a UIO of unit there in the end. And the code inside of here is this for expression that you see from here to here. So one thing we can tell right away is that when this for expression runs over here, we're going to get a 2-element tuple over here. First element's going to be the result of the transaction, and then the second value here is going to be the balance of that transaction. So the for expression runs from here to here, and I'll go ahead and include the commit in that as well. And you can see inside of here, what I'm doing is another for expression. And if this looks too complicated to have one for expression inside of another, of course you could pull this out into a separate function if you want to do that. But if you just focus on this code right here, what I'm doing with the account is say, let's try to withdraw the amount that we're given, and that'll give us a success or failure result. And then I want to call get balance on that account, and that will get us the balance information. And then inside of yield, all I do is return that result and the balance as a 2-element tuple right there and call commit on it. Now, once we have this information here, I call print line with the amount, result, and the balance. So we'll have that information output here. I was pausing for a moment because I didn't remember why I wasn't returning that here, but I'm returning it because I'm just doing this debugging information here. If this was a little more real world, I should return these 2 values over here. But because I'm just printing the information out right here, I can return unit. And as a quick reminder, I call or die here because when you call console.println, it's going to have this IO exception value here as a potential error. So I call or die, and that gets rid of that error. So then the error type is a nothing, and then we can use the UIO type here. Okay, so I've explained this code here, and I explained this code here. So now let me scroll back up here. We could take a look at the bank account class. The bank account class goes from here to here. And at the top up here, you can see that the bank account takes a constructor parameter called balance, and that's going to be a TREF of int. And then inside here, it has 2 methods. One is called withdraw, the other one's called get balance. So the way withdrawal works, and this is interesting here, you can see that returns an STM value, and that is a great indicator that there's not going to be any committing done in here. When you see STM here, that's an indicator to you that you're going to have to call commit yourself. And I note that right there, that it's not called inside of here. Actually, I'm going to go ahead and read this up here. This method returns an STM action that, when executed, will return a Boolean. So you see that right there. The method uses a for comprehension to sequence two STM actions. And what I mean by that is that there's a balance.get, which is an STM action right there. And there's this update right here. So those are both happening inside this for expression. And as I note in this next line right here, the use of STM in this for expression like that ensures that this operation is atomic. It will either complete entirely or not at all. So in this case, when it completes, we'll get a Boolean value here. Also, recall that the nothing value indicates that the function cannot fail. So going back to the for expression, you can see here we call get on balance. So balance comes in as a constructor parameter. And that gets us the current balance as the start of our transaction. And then this algorithm inside of here, I believe I covered that in the introductory presentation on STM and TREF. And the way it works is that it checks if the current balance is greater than or equal to the amount, then let's go ahead and update the balance with this algorithm right here. So we'll subtract the amount here from the current balance, and that will be our update. And then I'll return true here. So I have as true, and that gives us true in this position here. Otherwise, if we don't have enough money in the account basically here, then what we're going to do is call STM succeed, but we'll give it a false value, and that gives us a false value here. And again, to reiterate, before I leave this for expression, I want to note that everything inside of this for expression here is treated as an STM transaction. So the get and the update are considered to be one atomic transaction. And finally, inside of our bank account class, we have this other method, and it's called getBalance. And all it does is call get on the balance. And because balance comes in as a TREF, when you call get on that, it's going to return an STM value here. And of course, in this case, it's going to be an int because we're working with a TREF of int right there. Now, if for some reason I had called commit right here, then I want to be clear that this would not be an STM value. It would be a ZIO value, and then you would have the type information inside of here. But I'm not doing that, so I will go back to the previous code like that. And again, as a final note, anytime you see an STM value coming out of a function like this, that means that you're going to have to call commit after you use this function right here. So you'll see get balance is right here, and I call commit on it right there. Okay, I hope that all makes sense. I can't really get all the code on the screen at one time, but I have reviewed that code, so let's run it real quick. And to get the purpose here, take $50 out, try to take 70 out, and then take 30 out. That's what we're going to try to do over here. And over here, you see the withdrawal output. That's coming from these lines right here. The first one is withdrawal of 50 succeeded. The new balance is 50. The second one is withdrawal of 70 failed. New balance is still 50. And then finally, withdrawal of 30 succeeded. New balance is 20. And then our final balance is 20, which is exactly what we expected coming out of these transactions over here. So as usual, I'm going to encourage you to check this code out of GitHub and then change anything you want in the code to get yourself more familiar with the TREF type and the methods you can call on it, like make and commit and update and get, and also working with STM types like I show here, and working with TREF and STM types in this area here as well.